In this lecture, we will discuss about the conversion of internal energy in terms of Maxwell Boltzmann partition function. So the internal energy is denoted by U. So internal energy is denoted by U, and if you want to convert this internal energy in terms of partition function, so you must proceed as: first of all, take the derivative of this partition function with respect to the temperature. So here we have the derivative of this partition function with respect to temperature at constant volume. So apply derivative on both sides. So when you take the derivative of this exponential function, so first of all I recall the derivative of exponential function: d divided by dx e power box x. If you have a box and a variable x and you want to take the derivative of this function, so the result is e power box x same and the derivative of the box. We don't have concern for in the general formula that what thing is in the box, either there's any large function or a small function. It's a constant value like a, or it's a very large function in terms of a variable. So here we have variable ei divided by kt. So you must take the derivative of this power in the multiple. So I repeat the formula again. So if you have e power box just, so the result is e power box into the derivative of the box. Just simple, just drop the x. So here the function as it is, and here is the function which is e power ei divided by kt, and the derivative of this whole power according to rule. So when you take the derivative of this thing ei divided by rt, so here ei divided by r is constant value, so ei divided by r constant is right at the left hand side. And when you take the derivative of 1 over t, so what you will get d upon dt, or in simplest manner I can take d over dx 1 over x. So the method is d over dx x minus 1, and then put the minus 1 at the left hand side, and then add, subtract 1 from the power. So you will get minus x minus 2 and minus 1 divided by x square. So in this manner you will get minus 1 over t square, the derivative of 1 over t. So finally substitute the values in this manner. Here ei divided by kt square e power ei divided by kt. So now dz divided by dt at constant volume is equals to 1 over kt square summation ei into ei into kt. So the value having subscript I is always at the right hand side of the summation. Keep in mind. So when you put this kt square at the left hand side, so the relation is something like that, and after that we have another relation u is equals to n summation ei into exponential ei divided by kt divided by summation E into EI divided by KT. So how you will get this expression? So it's our previous work that if you have a partition function, a Boltzmann distribution law, and you have total energy summation. So when you divide this total energy by capital N, so you will get this thing, because capital N is equals to summation Ni. So now divide both the numerator and denominator by N naught. So Ni divided by N naught is equals to e power Ei divided by Kt. So in this manner you will get this expression. So after that, this thing is known as partition function, which is Z. And now U is equals to nkt square divided by Z dz divided by dt. How you will get this relation? So here summation Ei into Ei divided by Kt is equals to Kt squared dz divided by dt. So this side summation Ei divided by Ei e power Ei divided by Kt, and this expression summation Ei e power minus Ei divided by Kt. Put this value, this whole value of this function here in this place. So you will get n divided by z into Kt square dz divided by dt at constant volume. So finally, this is another mathematical process. Let us see. If you have dou divided by dou t, dou is the partial derivative, or in simple manner I can write d divided by dx ln x. So the result is the derivative of ln x is 1 over x, right? The derivative of x is 1 over x and dx divided by dx, right? So if I put another type variable d divided by dy and ln x, so the derivative is 1 over x and then dx divided by dy, right? So this is the general formula, keep in mind. So here when I take the derivative of this thing, dou divided by dou t ln z, so you will get 1 over z and then dz divided by dt, right? First of all 1 over this thing and then the derivative of this with respect to this. So if you see the previous step, which is the solution of this thing, right? So we are able to convert this solution into the question. So finally you will get this type of relation in this manner. So it is the conversion of internal energy into in terms of partition function. For 1 mole of gas, number of particles is equals to total number of particles is equals to Avogadro numbers. Avogadro numbers definition says in 1 mole of any substance contain 6.02 x 123 numbers, which are known as Avogadro numbers. So for 1 mole of gas you can replace this capital N by Na, and when you replace this capital N by Na, so Na into K is equals to R. How? This is very famous relation, K is equals to R over Na. So put R at the place of this thing, so you will get RT square d ln z divided by dou t at constant volume, which is the internal energy in terms of partition function.